Hello friends, welcome to Shiksharthi. In this video, we'll be solving questions of exercise 7.3 on coordinate geometry. So let's start. Now when we have a look at the questions, we see that the first question, second question, third, fourth and fifth basically talks about the area of a triangle or area of a quadrilateral. So this is the formula that we are going to use throughout. Now this is the area of a triangle, right? This is the formula that we'll be using. So question number 1 says find the area of a triangle whose vertices are. So question number 1, subpart 1. So you are supposed to find out the area of the triangle whose vertices are. So let's say the triangle. This is the triangle ABC. So here when we are using the formula, please keep in mind that this is A, this is B and this is C. I mean what I intend to say is A is x1, y1, B is x2, y2 and C is x3, y3. So the coordinates are 2, 3 followed by -1, 0 followed by 2, -4. Now please remember, without this also you can do it. Now this is not the only way in which, since all the three coordinates are given, and in all our videos when we have been solving questions over a period of time, we have always been talking about the basic way and the best way. Now this is the basic way. Basic way here is you know the formula in advance and then you're using it. Even if I do not know the formula, still I can do it if I know that the area of a triangle is half into base into height. So all you need to do here is you need to calculate the length. So here we can say this is nothing but half into BC into the height. Let's say the height here is AD. In this way also we can calculate the area, but the only hitch here would be how to calculate the coordinates of D. That could be the only hitch. Because in that case, if I know that this is an equilateral triangle or this is an isosceles triangle, in that case it becomes easier to decipher that BD will be equal to DC. But if this turns out to be a scalene triangle, then you will be compelled to use this formula only. So in short, let us just use this formula. And for further discussions, please remember that even if you do not know the formula, still you can use this formula, which is half into base into height, as far as the area of a triangle is concerned. And you use this formula, it becomes easier if all the three coordinates are given. And along with that, if you have an additional piece of information which says that the triangle is either an equilateral triangle or an isosceles triangle, then you can do without this formula. Okay. So if I were to use this formula, so now I know that area of the triangle ABC is nothing but half into x1, which is 2, into y2 minus y3. Now this is y2 minus y3, which is 0 minus 1 minus 4 is 4, plus x2, which is -1. Let me put this in bracket, multiplied with y3 minus y1. So y3 minus y1 is -7, plus x3 which is 2, multiplied with y1 minus y2. So y1 minus y2 is 3. Let us see what does this come out to. So this is 8 plus 7, 15 into 6, 21. So let's say this comes out to be 10.5 square units should be the area. Talking about the second part. So the second part also, you have a similar type of a question in which the coordinates are given to you and you are supposed to find out the area. So what I am doing here is I am not changing the diagram and I am letting the diagram remain the same, and instead I am just changing the coordinates for the second part. I am using the same diagram. So I'll say the area of the triangle ABC is equal to half. Now let me first substitute the values. So it is -5, -1 followed by 3, -5 followed by 5, 2. So what is the value of x1 here? Minus 5 into y2 minus y3. So y2 minus y3 is minus 7 plus x2. So x2 is 3 in this case, multiplied with y3 minus y1. So 2 minus 1 is 3 plus, so we have x3. Now x3 is 5 here, multiplied with y1 minus y2. So y1 minus y2 is minus 1 plus 5. So which is 4. So 20, 29, 29 plus 29 plus, how much is this? So 29 plus 35. So 29 plus 35 is, can I say 64? Which is equal to 32 square units. This should be the answer. Let's move on to question number 2. Now question number 2 says, so it says, in each of the following find the value of k for which there are 3 points, the points are collinear. So it is already given that there are 3 points which are collinear. So since we have discussed it in other videos also, 3 points being collinear means what? All the 3 points lie on the same line. So the points here are 7, minus 2, 5, 1, followed by 3, k. So many ways of doing it. As you recall, we have done it with the help of slope. Now here I can use this formula also, because for 3 collinear points, the area of a triangle that will be formed is 0, because there wouldn't be any triangle that can be formed with the help of 3 collinear points. On the contrary, a triangle is formed because of 3 non-collinear points. Okay, so either I use this formula and equate it to a 0, which gives me the value of k, or I can use the slope concept. Now when I am using the slope concept, I can say that the slope of AB, if this is equal to the slope of AC, that means this is nothing but a straight line. Is this correct? No, this may not be correct necessarily, because when I am saying slopes of 2 lines are equal. So now when I am saying slope of line, there are 2 lines which are equal. Either they would be nothing but the same line, or there will be 2 lines which are parallel to each other. But in this case, let us see whether this thing is correct or not. Now let us say that this is a point. We know that the line starts, there is a line segment AC, wherein we have an intermediate segment like B. Now if I say the slope of line AB is the same as the slope of line AC, given that AB is lesser than AC, then the 3 points have to be collinear. So anyway, slope of AB becomes what? y2 minus y1, which is 3, divided by x2 minus x1, which is minus 2, should be the same as y2 minus y1, which is k plus 2, divided by x2 minus x1, which is minus 4. So from here I'll be able to say that k plus 2 is equal to a 6, which means k is equal to 4. Okay, talking about the second subpart here. Now the second subpart is more or less the same question, so if you wish you can solve it yourself using the same. So, but anyway, we'll solve it together. Now for the second part, I'm using the same diagram. The only thing that I'm going to do here is I'll change the coordinates as we had done in the first question. So let us say that there are 3 points which are collinear to each other, and the coordinates which are given to you here are 8, 1, k, minus 4, and the last that they have given to you here is 2, minus 5. So using the same condition, can I say minus 4 minus 1, which is minus 5, divided by k minus 8, should be the same as minus 5 minus 1, which is minus 6, divided by 2 minus 8, which is minus 6. So from here we will be able to say that k minus 8 is equal to minus 5, Further on, we'll be able to say that k is equal to a 3. As advised, this is the best way of doing it, though if you want, this is the basic way wherein you can use this formula, and when you are using the area of a triangle, now this is area of a triangle formula, in that case if there are 3 points which are supposed to be proven that they are collinear, in that case the area has to be equated to a 0. Let's talk about question number 3. So question number 3 says, find the area of a triangle formed by joining the midpoints of the sides of a triangle whose vertices are given to you. So let me first draw the triangle here. And then let's talk about the triangle which is formed because of the midpoints, when you join the midpoints. So let's say the triangle that has been formed here is PQR. Now let me fit in the coordinates first. So 0, -1, followed by B, followed by C. Okay, now again there are two ways of approaching this question. One is, if you have already seen my videos on medians. Okay, so there are two ways. So if you have already seen, if you haven't seen, this gives you an avid opportunity to go through my videos on geometry, especially I am talking about median. So wherein when you are joining the midpoint, so you can use the midpoint theorem here, right? And then, so if when you are using the midpoint theorem, you can find out the area of the original triangle, and then maybe you can say that the area of this triangle which will be formed here would be 1/4 or whatsoever it is, if you know the theorem. If you don't know it, in that case you can find out the coordinates. So for example, here the coordinate would be what? 0 plus 0 divided by 2, -3 plus 1, which is 2 divided by 2, which is this, 2 plus 0 divided by 2, which is 1, 1 plus 3 divided by 2, which is 2, and here you will say that this is nothing but 0 plus 2 divided by 2, which is 1, and this is 0. Now you can use the formula and you can say that the area of the triangle PQR is equal to half of, and we'll use x1. So here also we said x1, x2, x3. We could have taken it this side also, doesn't make any difference. So x1, x2, x3. So x1 is 1 multiplied with, so y2 minus y3. So y2 minus y3 is 1 again, plus, now we have x2. Now what is the value of x2 here? Again 1 into y3 minus y1. So y3 minus y1 here is, y3 minus y1 is 1 again, plus, now we are talking about x3. So x3 is 0, so 0 multiplied by anything. Don't waste your time here. Don't waste your time in trying to figure out which value is this. So 1 plus 1, 2, 2 divided by 2 is again 1 square units. Right? Okay, so was this the first part? Okay, this is not. So find the ratio of the area of, find the ratio of this area to the area of the given triangle. Okay, so now in that case, when you are finding out the ratio of this area to the ratio of the given triangle, there are two ways of approaching this. As I said earlier, if I know the midpoint theorem, I can say that, this is, you are dividing this side into a half, you are dividing this side into a half. So you will just use the concept of BPT, which is basic proportionality theorem, and you will be able to say that this triangle gets divided into four congruent areas using the midpoint theorem. This is one way. The other way here is find out the area using the formula, which is nothing but half of, so x1, x2, x3. So x1, which is 0, don't waste your time for the other one, plus x2, how much is x2? 2 here, multiplied with y3 minus y1. So y3 minus y1 is 4, plus x3. What is the value of x3 here? So x1, x2, x3, which is 0 again. So don't waste your time. So this comes out to be 4 square units. So what is the ratio of the triangle? So the ratio of their areas, area of the triangle PQR is to the area of the triangle ABC is equal to 1:4. This is the answer. This you could have done it without even taking the coordinate geometry, and you could concept, and you could have simply done it. I'm talking about the second part of the question, could have been dealt with the help of midpoint theorem only. Okay, question number 4. Now question number 4 says, find the area of the quadrilateral whose vertices taken in the same order. So let us say that there is a quadrilateral. Let's say this is B, this is A, this is B, this is C, and this is D. And the coordinates are -4, -2, followed by -3, -5, followed by C, which is 3, -2, followed by 2, 3. Right, now when you are supposed to find out, you will say that, oh, we do not know how to find out the area of a quadrilateral in terms of coordinate geometry. So don't hurry up with this, and you can simply divide this into two parts, wherein this is your first area and this is your second area. So let us say the area of the triangle ABC, and then I have to add this to the area of the triangle taken in the same cyclic order, which is CDA. When I do this, I'll be able to find out the area of the entire quadrilateral. So let me use the same logic here. Now let me use the same formula which says x1, which is -4, into y2 minus y3. So y2 minus y3 will be -5 plus 2. Now -5 plus 2 is -3, plus x2, so the value of x2 here is -3, into y3 minus y1. So y3 minus y1 is 0, plus the last part of this. So when you are doing the last part, so you have to take x3, so x3 is 3 multiplied with y1 minus y2. So y1 minus y2 is just like saying -2 plus 5, which is 3. So 9 plus 12 is 21 by 2. So let's say this is 21 divided by 2. Let's find out this area as well. So this is half into, so x1, x2, x3. So x1 is 3 into y2 minus y3, y2 minus y3, which is 5, plus x2, which is 2, into y3 minus y1. So y3 minus y1 is -5, plus x3, which is -4, multiplied with y1 minus y2. So y1 minus y2 is -5. So let's see how much does this come out to. Okay, 15 plus 20 is 35, 35 minus 10, 25, 25 divided by 2. Now when I add these together, we get 46 by 2, which is 23 square units. So, and what have they asked you to find out here? Okay, they have asked you to find out the area. Let's see, the values that we had taken here are correct here or not. -4, -2, yes. -3, -5, 3, -2, and the last one that we have taken here is 2, 3. Let me see that the calculations that we done here are correct or not. Okay, let me check this value once again. So when I'm talking about the area of the triangle ABC, this is half of x1, which is -4, into y2 minus y3. y2 minus y3 is -3, plus x2, what is the value of x2 here? -3, into y3 minus y1. Now y3 minus y1 is just like saying minus, so y3 minus y1 is a 0, okay, and the last thing here was x3, which is 3, into y1 minus y2. So when we are saying y1 minus y2, so this is 9 plus 12, which makes it 21. Okay, let's see whether this calculation that we have done is correct or not. Maybe I feel that there is something wrong here. Let's see how. Now I'm only checking this. I'm very confident about these two. So when I'm checking this, what am I supposed to do? I'm supposed to take the value of x2. So x2 was 2 multiplied with y3 minus y1. Now when I'm taking y3, which is this, minus y1, so this should come out to be a plus 5. Okay, so when we do this, we get this as 35, and 35 plus 21 divided by 2 makes it 56. Now 56 when divided by 2 gives me the answer as 28 square units. So please check your answer. The answer should be 28 square units. Talking about the last question, which is question number 5. So when we talk about question number 5, it says, you have studied in class 9, chapter 9, example 3, that a median of a triangle divides it into two triangles of equal areas. Verify this result for triangle ABC whose vertices are this. Okay, so for this you can use whatever we have done here. So it says the median. Okay, so let me just use this. Let's say this is A, this is B, and this is C. Let me say that there is a median that I am drawing from here to here, such that this side gets divided into two equal halves. Okay, so here this is 4 comma minus 6. So let's say ABC is what I am taking, x1, x2, x3. 3 comma minus 2. And the last one is 5 comma 2. So in that case, if I want to say that this point is D, which is the median point, so how much is 3 plus 5? 8 divided by 2, 4. 2 minus 2, 0. Okay. Now what do I do further? Now further here is, we just need to find out the area of the triangle. So area of the triangle ABD is basically what? So we'll be using the same. So when we are using the same, we'll say this is half of x1, which is 4, into y2 minus y3. So into y2 minus y3, which is minus 4, plus x2, which is 3, into y3 minus y1. So y3 minus y1 makes it 8, plus then you are getting x3. So what is the value of x3 here? 5, into y1 minus y2. So this is y1 minus y2, which is minus 4. So minus 20 plus 24 is 4, right? 4. So here you are getting the area as negative. Now please remember, the area can never be negative. So let's check the values once again. So when we are checking the values, x1 here is 4, y2 minus y3. So y2 minus y3 is minus 4. Next x2 here is 3 into y3 minus y1. So y3 minus y1 here is 8 again, plus 5 times of, which is x3, 5 times of y1 minus y2. So y1 minus y2 makes it minus 4. So this is correct. Minus 20 minus how much? 16 is how much? Minus 36. Minus 36 plus 24, minus 12. Minus 12 divided by 2 is minus 6. But we know that the area can never be negative. So take it as 6. Now find out the area of, okay, now this we were finding out. We did not find out the area of ABD, we found out the area of ABC. Now let us find out the area of ABD, which is just like saying this is 4, which is x1, into y2 minus y3. So y2 minus y3 is minus 2, plus x2, which is 3, into y3 minus y1. So y3 minus y1 makes it 8. So y3, I'm sorry, it is y3 minus y1. So okay, y3 is 0 and y1 is minus 6. Plus, how much should I get now? So x3 is 4 multiplied with y1 minus y2. So y1 minus y2, does it give me minus 4? It does. So minus 16, minus 8, minus 24, minus 24 and 18. So minus 24 and plus 18 gives me plus 6. plus 6 divided by 2 gives me 3. So can I say that the area of the triangle ABD divided by the area of the triangle ABC is 1 by 2, which proves that the median of a triangle divides the area of the triangle into two equal parts. So if this area is 3 square units, this area will also be 3 square units. So you see that this is a lengthy way of doing it, but on a second thought, you could have done it like you can drop a perpendicular here as we discussed earlier. You can find out the area of this triangle, and without getting the coordinate part also you can prove it. Without taking the coordinate part also you can prove it, and you can prove it with the help of BPT or midpoint theorem, right? So we have tried our best to discuss the complete and the correct solutions in a fantastic manner. If you feel the same, please do not forget to like, share and subscribe to our channel. If you have already done so, click on the bell icon and select all so that you get regular updates from us. Thank you so much. Until next we meet, goodbye.